Hey, good afternoon. Welcome to Sagamata Online Academy, the Academy of Excellence and Positive Results. All right, so we are still looking at acids, bases, and salts. We did acids. Now we are to look at bases. So we're still looking at acids, bases, and salts. Okay, so specifically, we are looking at bases. Okay, so what is a base? A base is simply an oxide or hydroxide of a metal. A base is simply an oxide or hydroxide of a metal. Right. Okay, that is what a base is. Okay. Or you can simply say a base is simply a proton donor, a proton acceptor rather. A base is simply a proton acceptor. Okay. So you can also define a base in that way. Then what is an alkalis? An alkalis is a substance. An alkalis, a substance which when dissolves, which when dissolves, or which when dissolved in water, produces the hydroxide ions. The hydroxide, okay, ions, negatively charged. Negatively charged. So that is what an alkalis is. An alkalis is simply a substance which, when dissolved in water, okay, produces the hydroxide ions which are negatively charged. Now, there's a statement that we always say that all alkalis are bases, but not all bases are alkalis. And the reason for that is that we have what we call soluble bases and insoluble bases. So all those bases that dissolve in water are called alkalis. And then those that do not dissolve, those we classify them as insoluble bases. So all bases, all alkalis are bases, but not all bases are alkalis. Because among the bases, we have those that can dissolve and also those that cannot dissolve. So let's look at examples of alkalis. Examples of alkalis. Okay, when we say examples of alkalis, we are referring to examples of bases that can dissolve in water. So number one, we have sodium hydroxide. Sodium hydroxide, which is this one here. Then number two, we have potassium hydroxide. Potassium hydroxide. Okay, this is this. Okay, then you can also have ammonium hydroxide. Ammonium hydroxide. Okay, ammonium is NH4, then you put hydroxide like that. So these are some of the examples of alkalis, or bases which can dissolve in water. Then what about insoluble bases? So let's also talk about examples of insoluble bases. Okay, insoluble bases are those bases which cannot be dissolved in water. What are they? For example, you have copper 2 oxide, copper 2 oxide. Okay, the chemical formula is this one here. Then we also have zinc oxide. Zinc oxide. The chemical formula is this one here. Okay, and then we have also iron 3 oxide. Iron 3 oxide. Okay, so the formula is here. Please pay attention to the radical, to the valences. Okay, and then finally we also have lead 2 hydroxide, which formula is this one here. Okay, 2, like that. If you're finding it's difficult for you to understand chemical formulas, I did a video on this one, so check out that video so that you'll see how we're coming up with these chemical formula. All right, so now having talked about this, I want us now to look at ionization of alkalis. Ionization of alkalis. So ionization of alkalis. Ionization of alkalis. Now remember that ionization is simply the process of making ions. The process of making ions is what you're calling as ionization. So for example, we have sodium hydroxide. This can be ionized into sodium plus as well as hydroxide minus. So this is aqueous, this is also aqueous. All right, so B, you can also put potassium hydroxide, which in this case is going to give us K plus and the hydroxide minus, all of them in aqueous phase or state. Okay, you can as well have ammonium hydroxide, which in this case is going to give us this plus and this minus, all of them in aqueous phase. Okay, and finally we can have maybe calcium hydroxide. So this is going to ionize into calcium 2 plus and 2 minus, like that. So this is going to be aqueous and aqueous here. So these are some of the examples of bases which can undergo ionization. Okay, so take note of that. All right, so let's continue. The next item that we need to look at perhaps is the strength of bases. The strength of bases. So I want us to look at the strength of bases. Strength of bases. Strength of bases is simply the measure of its ability to produce hydroxide ions. This is simply the measure of its ability to produce hydroxide ions. So under this, we need to talk about weak bases or alkalis. Okay, weak alkalis or bases. Okay, so what are these weak bases or alkalis that we're talking about, or alkali. Now, alkali is the plural word of alkalis. Okay, so um, what are these weak bases? These are bases which can, partially ionize when dissolved in water. These are bases, if you want, you can say these are, alkali, which can actually partially ionize in water. Bases can partially, which can partially ionize when dissolved in water. Okay, so that's what weak alkalis, weak bases are. So of examples of uh, weak bases include air, ammonium hydroxide, And please take note that when it comes to weak bases, we normally show their ionization using half arrows pointing in both directions. So in this case, we're going to have a half arrow pointing in that direction and the other one pointing in the opposite direction. So this is going to give us ammonium ion plus hydroxide minus. So this is still aqueous, this is aqueous, and this is aqueous. All right, so what about strong alkalis? Now these are the ones now that completely dissolve in water. Strong alkalis. These are bases. These are bases. These are bases which ionize completely, when dissolved in water. Okay, so examples, we have sodium hydroxide. Sodium hydroxide is a strong base which can ionize completely. And please pay attention to the arrow here. If you're dealing with a strong bases that can ionize in water, we use a single arrow pointing in one direction. So it's a full arrow as opposed to using a half arrows. So we're going to have sodium plus this. So this is aqueous, and this is as well aqueous. And then B, you can also have potassium hydroxide, which is going to be potassium 2 plus and O minus, like that. All of them in aqueous phase. All right, you can also have perhaps calcium hydroxide. You can also have calcium hydroxide, which is going to give us calcium 2 plus, and the 2 here comes the friend of hydroxide, so it's going to be 2 minus, like that. So this is going to be in aqueous, this is aqueous, and this is aqueous too. So this is what you need to know on the strength of bases. Now, having talked about this, I want us now to look at what we call properties of bases. So properties of bases, and these will be classified into two. We're going to look at what we call physical properties. Okay, so let's begin with physical properties, and then we'll come again to the other properties, which are chemical properties. Let's classify them so that we can understand them better. So number one, in terms of physical properties, we know that all bases have a pH value greater than 7. Okay, have a pH value greater than 7. So this is demonstrated on the pH scale, okay, where you have which ranges from others they say 1, others say 0, from 1 to 14, okay, passing through 7, which is a neutral point. So 1, okay, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, and then 14. So what you're saying is that all bases have a pH value of greater than 7. Now remember that 7 is neutral. Neutral means it's neither an acid nor a base. So the substance that falls at 7 is neither an acid nor a base. So as you come this side, from 7 to 1, this is acidicity, or this is acidic. And from 7 to 14, this is basic or alkalinic. Okay, so any substance that falls between 1 and 6.29, that substance is acidic. And any substance that falls between 7.1 to 14, that is a basic substance. So we're saying that all bases have a pH value that ranges between 7 and or should we say 7.1 and 14. So that's number 1. Then number 2, which is B, we need to also understand that bases turn red litmus paper blue. Bases turn red litmus paper blue. Okay, so if you get red litmus paper and you dip it into a substance that has some basic properties, that substance will turn the red litmus paper blue. And then we have C. The other one could be that the physical property could be that all bases, taste bitter. Okay, all bases taste bitter. All right. Okay, and they feel soapy or slippery between fingers. So between your fingers, they feel, soapy or slippery. So these are some of the, physical properties of bases. Now let's pay attention to the other aspect, which is the chemical properties of bases. All right, so let's talk about chemical properties of bases. All right, so number 1, bases react with the acids to form salt and water. Bases react with the acids to form salt and water. Okay, let's take an example. Now, before we take an example, this reaction is called neutralization reaction. This reaction is called the neutralization reaction. It's a reaction between an acid and a base to produce salt and water. So let's take an example. Let's call this as A. Let's say we have sodium hydroxide, which is a base in this case. Okay, reacting with an acid. Let's pick an acid. Let's use hydrochloric acid. This is an acid. So these two will react to give us sodium chloride, which is our salt, and water, which is another product. So this is water. So when you have an acid and the base reacting together, you form salt and water. Or you have a base reacting with an acid, whichever arrangement, you still have salt and water. Maybe let's take another example. So this is a neutralization reaction. We can also have, let's say, an insoluble base, which is in this case copper oxide, reacting with an acid. Let's use sulfuric acid. This is going to give us a copper sulfate plus water. So this is our base, this is our acid, and this is our um, salt, and this is our water. So this is still a neutralization reaction. So a neutralization reaction always gives you two products, and which are salt and the water. So another property, chemical property, is that bases react with ammonium compounds to produce salt, water, and the ammonia. So bases react with the ammonium compounds to produce three things. What are those things? Or what are those products that are being produced? We have salt, we have water, and the ammonia gas. Example, let's take an example. Let's say we have calcium hydroxide, which is a base reacting with an ammonium compound, which in this case is ammonium nitrate. Okay, so this is going to give us calcium. This is going to give us calcium nitrate, calcium nitrate, plus it's also going to give us water, and it's going to give us ammonia, NH3. Okay, so we know that ammonia is a gas, so it should be in gaseous state. Water, liquid state. Then calcium nitrate, this is a soluble salt, so it's going to be in aqueous. And then you have ammonium nitrate, this is also an aqueous phase. And then you have calcium hydroxide, which is also in aqueous phase. Okay, maybe another example that we can take is sodium hydroxide reacting with which one should we use? Okay, let's use ammonium chloride. So this is going to give us sodium chloride, which is a salt, plus water, plus ammonium, still gas, liquid, aqueous, and aqueous. Okay, so that is also another property. The third property is bases react with the soluble salts to form precipitates of insoluble hydroxide. So saying bases react, they react with a solution of soluble salts, okay, to form precipitates